Hey everybody, welcome to the Chapter 3 Section 4 Notes Modeling with Quadratic Functions. In this video I'm going to show you how to use Desmos to run a quadratic regression when you're given a handful of points or a table of data. So I have all the instructions written right here. This is mostly for my students. I'm just going to jump ahead to the first example. So I'm going to write an equation of a parabola that passes through these points. And yeah, I have the answers filled out already to kind of save time. So what I'm going to do is if I have a collection of points, you need to plug those into a table in Desmos. So Desmos is capable of graphing individual points. Like if I want to graph 9, comma 1, I can do that. Um, but if you have a collection of points and you want to like assess data from that, then then you're going to want to do a table. So what you're going to want to do here is you're going to go to add item, and then you'll go to add table right there. And then you'll just type in all your x values into the x1 column and all your y values into the y1 column. So let me get this out. I did this ahead of time. So here are my points again. X is -1, 0, and 2. And so I have -1, 0, and 2. My y value is 4, 1, 7, 4, 1, 7. So if you read them from left to right, you have your ordered pairs: -1, comma 4, 0, comma 1, 2, comma 7. Okay. Um, the reason why there's a little one up here is this is subscript. So x sub 1, y sub 1. That's because you can plug in as many tables as you want. So the subscript will keep increasing if you keep plugging in more tables on the same graph. For me, I just prefer to open up Desmos in another tab if I'm going to do more graphs. Um, so yeah, I just keep everything in one table. So all the points are graphed here. If you want, you can click to see the labels. So what we got to do now is run a quadratic regression. And a regression is a function that is supposed to model data or approximate data. Um, so oftentimes you have data that's not 100% perfect, like it doesn't perfectly go through a parabola, but the points are relatively close to it. So what you're going to have to do is you're going to have to type in the approximate standard form quadratic equation. So let me show you what I mean by that. So right here is the standard form quadratic equation: y equals ax squared plus bx plus c. We need to approximate that because if you use equals, Desmos gets kind of confused. But if you use this symbol right here, the tilde, it will know exactly what to do. It will approximate an equation. So what you'll do here is you'll click in line 2, and you have to type in y sub 1 and x sub 1 anytime you want to use the x and y variables. You have to put the sub 1 because it needs to reference it back to that table. If I just type in an x, it could just mean any x. But if I type in x1, now it knows I'm talking about the x values from that table. Okay, so I'm going to type in y sub 1, and typing in the subscript numbers is easy. You just type in y1 and then it automatically does it. And then don't type in equals. You'll want to, let's see here, you want to go here, click the ABC, and you'll see the tilde button right there. That's going to mean approximately equals in Desmos, okay? So, and then you type the rest of the formula: ax squared plus bx plus c, except every time you have an x, you got to do that sub 1, and then so I'm going to square it. So if you don't know how to square, you can click this, that'll square it, or you can click this, and that'll create an empty box for you to type whatever exponent you want. So ax squared plus bx plus c. And you see how I forgot to type in the sub 1 on the x? It's giving me an error message right here, but when I just do the sub 1, now it is giving me my line, or my parabola, I guess, of best fit. And so if I were to take this out, you can see my points are in green. These points in gray, these are, let me zoom in. These are your x and y intercepts. That's what's going on there. I mean, not x and y intercepts. This is your vertex, and that's your y intercept. There are no x intercepts. It's not touching the x-axis at all. But if it were, you could easily just click wherever it's touching the x-axis and it'll show you those values. So that's a really nice tool to have. It takes longer to do this in the TI-84, the TI-Nspire. So I'm going to write this down for my vertex. And I kind of skipped over this function part, didn't I? My function, it'll see that where it says parameters right here. Those are your coefficients for your function. If a is 2, you're going to have 2x squared. If b is -1, you're going to have minus 1x or minus x. And if c is 1, it'll say plus 1 at the end. So I wrote that down right here, y equals 2x squared minus x plus 1. Okay, so this function models the data perfectly because r squared is 1. So r squared stands for the coefficient of determination. What does that mean to you? It means, think of it like a percent. If 1 is a percent, that's 100%. So something's 100% correlated if r squared is 1. If r squared is like 0.9 something, then it's a very strong correlation. And then the closer that number is to 0, the weaker that correlation is going to get. So the r squared number is used to determine how strong of a correlation your regression function has in comparison to the data that you plugged in. Okay, so if you have an r squared value of like 0.2 or 3, that's a very weak correlation. But again, if you have 0.9 something, that's a pretty strong correlation. The closer it is to 1, the stronger the correlation is, the more accurate your function will be, and you can use that to predict data. So what I mean by predicting data is like I only gave you 3 points here, but then I can ask you a question like, what does y equal and x equals 4? So I'm going to use that this function to predict that data. So all I have to do is just type in x equals 4, and then you just have to find the intersection. So click right here where they intersect. Y is going to be 29. All right. So if I were to relate this back to my r squared value, if that r squared value is like a 0.3 or 4, that's a weak correlation, I wouldn't have much confidence that this number would be accurate because it would be kind of a bad prediction. But since r squared is 1, I know for sure it'll be 29. And if r squared is like 0.9 something, then it's good to use for your data for a good prediction. So yeah, if I can also type in y equals values. So I asked a follow-up question here. What does x equal when y equals 17? So like, what's the output? What's the input if your output's 17? All you have to do, again, just type in y equals 17 and look where they intersect. So I got to scroll down here a little bit. Click here, and these are my two x values when y equals 17. So it's pretty easy to use in that sense. So what I'm going to do now is I'll do one more example, and this will be kind of a more complete example because it's a word problem. So it says the table shows fuel efficiencies at various speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. So I got to plug all this into my Desmos calculator. So I'll go to a new graph, and I'll go to add a table. I'll type in all these values. So I did that ahead of time. Here they all are. And now I need to do my my quadratic line of best fit, right? Or quadratic curve or parabola of best fit. So you're going to go y sub 1 is approximately equal to. So we're going to go to the ABC, click approximately equals to ax sub 1 and then square it plus bx sub 1 plus c, not cx plus c. So my r squared is 0.9994. On my notes, I rounded it to the nearest thousand, so I just wrote 0.999. That's a very strong correlation. You're going to get some accurate predictions. What are your A, B, and C values? I rounded those to the nearest thousands place on my notes. So if any of these numbers rounded up, I would look at that fourth decimal place to see if it was 5 or bigger to round up that third decimal place. But yeah, here are my A, B, and C values. You can see I plugged those in here. And so I got a function that's approximately this, negative 0.014x squared plus 1.389x minus 7.524, okay? So yes, 0.999 is a strong correlation. My optimal driving speed, that would be find the vertex. This is a relationship between miles per hour and miles per gallon. So it's saying the slower, faster you drive, it's trying to show you your efficiency. So my optimal efficiency would be at the vertex. So you can see it gray as a gray point right here. So if you just click, it just kind of nails down that coordinate. Um, so yeah, what's nice is it's rounded to the nearest thousandths place for you. It's not giving you 100 decimal places. So I wrote down this number exactly as it is, 41.218 and 25.965. How would I interpret that? Well, your x values are miles per hours, your speeds, and your y values are your efficiency, your miles per gallon. So your optimal driving speed is about 41 miles per hour, and you'll get about 26 miles per gallon. All right. So then I can ask you follow-up questions like, what's your fuel efficiency at 89 miles per hour? That's an x value. So I'll go back here. I'll type in x equals 89, and then click at the intersection, and you get 2.01. So that means I'll get about 2 miles per gallon if I drive 89 miles per hour in whatever vehicle this is. Um, then I ask another question: what speeds will produce a miles per gallon of 10? So miles per gallon is a y value. So I need to go in here and type in y equals 10. You can delete it like I'm doing right now, or you can just exit out. Y equals 10. I got 2 points of intersections. So 14.926 and 81.511. So I wrote those down here. How would I interpret that? Well, that means I'm driving about 15 miles an hour or possibly 82 miles an hour. Okay? So I hope this video was helpful for you. Thank you for watching. Like and subscribe if you feel like it, and goodbye.